everyone. Thanks for joining. We'll give a couple more minutes to see if anyone joins in, and then we'll get started. I've run a couple of versions with this with our staff. This is the first contractor version that I'm doing. Feel free to jump in with any questions, and I'll try to answer any that you can. As well, this is there's a lot of questions out there, so this is kind of a first step overview of some of the pressing questions that we need to know. I wouldn't say that this is a comprehensive, especially a deep dive into the technical aspects of the refrigerant, but I'm sure most of your questions will be answered today. If there's anything that didn't get answered, please feel free to answer or ask questions in the chat. And if I don't have them, I'll certainly include them in the next next step in this as we get more information from the manufacturers and learn more about the products themselves. So yeah, we'll give a couple minutes. Everyone can hear me and see the screen. All right. Okay, let's get started. So, as we all know, most of these slides are geared to a good technical base knowledge. I've clipped and chosen the ones that are going to get the message out the best in the best amount of time. I'm going to dive into some of the more basic pieces of this in case there's any newer mechanics or business owners that it would be helpful for them to know the information, or if your business or you're a newer technician that didn't go through this R22 transition 20 years ago, then there'll be some helpful information in there as well. So, okay. So whenever we talk about a transition in our industry, we have to consider environmental safety and performance concerns. If we're going to make a change, obviously safety is top of mind. We also need to know that the product is going to perform as current products do, or in a predictable manner that we can adjust to. In this specific case, environment is the reason that we're making this change, just as it was the last time when we switched away from R22. So back through the 90s and into the early 2000s, ozone depletion was the top of mind issue. The use of CFCs and other ozone depletion products did obviously cause an issue with a hole in the ozone layer down in the South Pole. And as an industry and as a global community, we did get together and make some changes that ended up correcting that problem. And the ozone layer has largely healed due to the actions of our industry and others like it. So obviously the next challenge that we're facing is global warming and the climate impacts that has brought. So when we look into the next generation of refrigerants, the global warming potential, GWP, is a phrase you'll hear me say over and over again today. As global warming gases build up in the atmosphere, they are a heat trap, and they don't allow for heat to escape our atmosphere, which continues to build up mostly in the oceans, and that's what's driving most of these extreme weather events that we're seeing. So, as we talked about, refrigerant 22, Freon as it was called in the day, was a ozone depletion of 0.5 or 0.05. It obviously, that's a tiny amount, but it did a serious amount of damage. It had a GWP of 1810, and so moving into R410A, we fixed the problem of the ozone depletion, got that down to 0, but now our GWP spiked up to 2088. So there was a downside to that as well. Moving into the next generation, we've still got the ODP factor of 0, and now we've got our GWP down to 466, which is obviously a major jump. The new limit starting January 1st, 2025 is 700. There are 2 refrigerants that are being widely adopted by our industry that do meet the new max allowed GWP standard of 700. So the 2 that you'll see out in the industry are R32, which has been around for quite a while. If you're not aware, it is one of the major refrigerants that is blended into R410A. So we are used to R32 as a blend, and that continues into the new generation. R454B, which is the refrigerant that Trane has chosen and all the major North American manufacturers have chosen to go with, is a R32 blend as well. So when, I believe it's on another slide, but when R32 is blended with another refrigerant, which is a great mouthful of R1234YF, it actually, the 1234YF acts as a GWP limiter, which actually brings the GWP factor of R32 down significantly. So that's why it was mixed in to create 454B. R32 is actually, so it's obviously a great refrigerant that has been used for the last 20 years, and I think even previous to that. It will continue to be used because, one, we need it to build, to make the blend of 454B, but also because it actually outperforms other refrigerants in ductless products, and the technology in ductless products is better suited to R32. It was invented by Daikin. So as the transition happens, and with the GWP rating of 675, they're good. So they can continue to use their patented refrigerant in their ductless units as a pure refrigerant, not blended, after January 1st, 2025, which means that as part of this transition, there isn't a major switch, right? We're changing from one refrigerant blend that we've used for the last 20 years to a different refrigerant blend. There's no major innovations that need to be made to do this change, which was a major difference in R22. We'll talk about continuing through the presentation. So one of the issues that came up here when we were talking about using flammable refrigerants, which both R32 and R454B are flammable, is that we've used flammable refrigerants forever. One of the ones we'll continue to talk about today is propane. Propane is a staple in our households. We obviously use it for its flammability and for cooking, but it's also in most of our major appliances. Most of our refrigerators and freezers use propane, and it's widely been used as a packaged refrigerant for many years. The difference is when we're talking about using a flammable gas in someone's home and installing it as a split system, that's where the change happens, and that's where we need to be a little more concerned. So prior to 2010, the chart on the left was the standard classification system we used for flammable gases. Anything with a higher flammability is in the 3 range, lower in the 1. A's are non-toxic, and B's are highly toxic. So, for instance, so our natural gas not natural gas, any of the Freon and R410A that we've been using have been A1 refrigerants. So they've fallen into the most safe, most easily used category, and we didn't have any issues. Stepping into a new generation that is flammable, we needed to take another look because yes, these refrigerants are flammable, but barely. It is actually very difficult to ignite these gases. So it wasn't really even fair to call them flammable. So they created a new lower flammability rating of A2. So non-toxic, flammable, L for low. So a low flammability non-toxic refrigerant. So that's where the A2L comes from. This chart shows a comparison of the minimum amount of energy required to ignite a flammable gas and the speed at which it burns. So down here, obviously, acetylene is we use it every day in our torches, gasoline, propane, isobutane, and methane, otherwise known as natural gas. Very quick to burn and very easy to ignite. As we move away from the probability of an ignition event, we find ammonia, which is a very common refrigerant that in industry, especially in things like ice rinks, commonly used ammonia. And here we find R32. Up here, way at the top, with that even lower, the lowering factor of R1234YF. The reason that R454B is not actually listed on this chart is that the blend isn't a stable one. Just like R410A is unstable and will fractionalize, so will 454B. So depending on the state that it's in and the area of an air conditioning or refrigeration system that it's working in, it could actually range between these 2 points on its flammability range. But it is, of the two, it is even more the safer choice than R32. So when we look at propane, R290 is its refrigerant name. It takes 1 millijoule to create ignition. R32, 30 times that, 30 millijoules it takes to actually ignite R32, and 454B, 100 plus. It's very, very difficult to create an ignition with these systems. Well, how flammable actually is it? How fast is this going to burn if it does actually is created? What this, the 2% is basically a kind of like an air fuel mixture, right? As little as 2% of propane mixed into air is enough to create ignition. I think if I remember correctly, natural gas is 4 to 6%, something like that. R32, 14.4%. It's a tremendous increase. It would need to be highly saturated into the air for it to ignite at all, even with the required amount of energy. And 454B up there as well at 11.8% mixture. So how fast does it actually burn? 18 inches per second for propane. That's pretty quick, especially if you're sitting in front of a water heater that backfires in your face or something like that. When you talk about R32, 2.5 inches per second. You could get up and walk away, and it would have no problem staying in front of this thing. 14% of the speed of propane, and 454B, 2 inches. Like this, you'd barely see it move, right? Very interesting. Here's the testing chamber. They are not explosive at all. Even at high concentrations, they don't reach any point of an explosion limit, like even carbon monoxide, carbon dioxide, in enough concentration can become explosive. You can see, oops, it's running. There you go. You can see the flame ignite in the tube and just how slow this runs. So obviously, when we're installing any type of flammable system into a home, the safety is the biggest concern. And they've made responsible choices when choosing these refrigerants to meet the needs of the global warming potential with the safety factor of having these systems being serviced and installed in people's homes. So what's actually changing in our industry? Lots of safety labels, right? Every time we get more safety labels, it's not going to be long before our systems look like NASCAR. But obviously, they're all very important to people know before they even get close to the unit, they're going to know it's an A2L unit. As for Trane, they will have these red discs on each of the service ports labeling the type of refrigerant that's installed in the system, and the caps will have locks on them. So as part of this, I'll talk a little bit about tools as we go, but there are locking caps are very, very popular in the States because of theft issues of refrigerant and things like that. Less so up here, but there are special tools to that use to pop the valve cover off. As we know, Freon used green as its color code. R410A was pink. We're using a red stripe for R4 or A2L refrigerants. They can be mixed between 454B and 32 because they're already blended together. So putting them both into the same reclaim tank is no problem. But we don't want them obviously mixed with a 410 or 22 or any other type of refrigerant. The flammable ones do need to be separated into their own reclaimer with that red stripe on it to make the recycling centers aware that there is a flammable vapor in that system. With another safety feature, obviously pressure, mostly in the US, so southern US, if you leave a bottle, especially on its side, in a hot truck or hot environment, it could burst, especially if it's been overfilled. Our 410A tanks today have burst discs built into them that if they get to a dangerous situation, the disc will burst and expel the entire contents of that bottle out to lower the pressure and stop from an explosion event. With A2L cylinders, the same is going to be true, but the benefit of this one is if it blows off, it will reseal itself once the safe pressure is met again. So it won't blow the entire contents out for the A2L ones. A2L refrigerants. So as with flammable gases, and this is where we're getting into a gray, one of the more difficult things for Canada in this conversation is we've never used flammable gases as a refrigerant before in the field, in installing hands-on. It's only ever been done in the factory. So there are limitations of how many bottles you can keep on your truck. Nobody keeps 6 25-pound cylinders on their truck, I would hope. Obviously, in our business, we do, but we use flatbed and open ventilated trucks to do that. So there is exceptions to that piece. But definitely we need, if you don't have ventilation in your trucks already, I would highly recommend that you do it. It just keeps everything, the heat that gets into our trucks can hurt tools and parts and rust out our black fittings and all that stuff. So this is the big question about Canada, and it's basically solved now, and we know what the plan is. Consider our business in distribution. We sell acetylene tanks, other flammable gases, and there are strict storage and transportation rules around how we do that. For us, the flammable gases like acetylene need to be in a caged. They need to be caged. In some cases, those cage needs to be sprinklered, and they need to be 6 feet away from anything flammable. Now, consider an air conditioning condenser containing a flammable vapor. As the building code said previously, that would mean that we would have to store our air conditioning condensers without any combustible packaging, caged and sprinklered, and nothing combustible can be 6 feet away from them. We can see why that would cause a big problem, both in our warehouse and in yours. So Canada hasn't adopted this. This change is, again, as with most of these regulatory changes, they are being driven out of the U.S. Department of Energy, and we're being forced to adapt. Most of these changes, they're in the right direction, but basically, except for the period of COVID and supply chain issues that brought, we've had a regulatory change almost every year since 2019 with the fan efficiency ratings that came in. So the thing to remember, what Canada has done, because they didn't need to go and change our DOE regulations, what we've done is changed our building code to allow for the A2L classification, because that didn't exist before, right? If we had an A2 refrigerant that was flammable, we would have to store them as if they were flammable gases like acetylene tanks. With the A2L classification, that new classification comes with some restrictions being lifted. So we can box these in combustible materials. We can store them like we've been storing them before. They don't need to be caged to a limit. right? So some of this information, if you don't know, the HRAI is our go-to resource for our industry for any regulatory changes, lobbying the government, and an information and training source. So some of these by and large, this slide deck that I'm presenting is coming from Train, but I've chosen specific information from the HRAI, and I want to give them credit because they obviously do a ton of work for our industry, and we owe them that credit. But if you go to the HRAI, they have a special page which I'll put up on the screen to get more information on this and really dig into some of those questions and answers that you may have if I can't answer them here. So when it comes to quantity of a controlled product in a storage or warehouse, non-sprinklered, we can have 20,000 pounds of this refrigerant in our warehouse. Sprinklered, we can get it up to 40,000 pounds, right? So give or take, let's say these units, a typical condenser may have 4 or 5 pounds in it. That means we can, rough math, we can have 8 to 10,000 air conditioners in our warehouse. I'm happy to say we don't store that many. So they've made the storage question easy to follow in this case. So this information did come right from the HRAI, hrai.ca/refrigerant transition. You'll see these green links here, and you can click on those to get any answers to these specific questions. And you can also reach out to them directly to ask specific questions and get direct answers from them. Refrigerant lines and tools. This is the stuff that's going to kind of change your day-to-day life. So the good news is that if we were around for the R22 changeover, the big question there was our pressures were doubling. They were going way, way up, and there was some concern that maybe they'll just blow up in our face. Obviously that didn't happen, but luckily with R454B, the pressures are coming down a little bit, not much, but a little bit, but that's actually given us a lot of leeway. And because R454B and R410A are actually very closely linked with that R32 base refrigerant, they've been more clear about the mixability. And what if I can't change the line set? Is that going to be a problem? Is that going to be, am I going to be okay? When they changed from R32, it was absolutely not. You have to get every ounce of refrigerant and mineral oil out of that system. We don't want any of it touching the new system. After a few years, they realized that it was okay if there was a little bit of mixing, and they ended up coming out with a 6% is what they decided was an okay mix rate for train systems to the old mineral oil and R22. They're not concerned about this in this case. So service valve sizes on these air conditioners, 5/16 on the liquid side. Very interesting, right? And then 1/2 inch for a 2-ton. We're not even getting up to 3/4 until we get to 4-ton, and 3/4 on a 5-ton. Line sizes, 3/4 on a 5-ton, right? 410A, we'd be 7/8, and if we went even too far on that, it'd be 1 1/8 inches, and you'd be welding every fitting, right? So this is going to make our lives a lot easier, especially if we do recommend moving towards, welding. If you're welding, half the nitrogen, we'll talk about that in a minute. But if you can't replace the line set, you are okay with these alternate line sets of 3/8 and 5/8 for a 2-ton. Obviously very common, 3/8 and 3/4 for 3-ton. They've given us some really good wiggle room here that if we need to go bigger or we're stuck with an existing line set, we'll be okay. With line sets, we can still continue to flare and use compression fittings. We can use pipe press systems that are coming out nowadays, and we can still continue to braze. Of course, brazing a flammable vapor, we need to be careful. Nitrogen is extremely important, especially when the refrigerant's been released in a service case. They put in this point about tin solder because back in the R22 days, the pressures were low enough that some people would use plumbing solder. to try to weld their lines together, and by and large, they got away with it. When it went to R22, it was absolutely not going to work. The pressure would have blown the joint apart. The pressure is coming down, but not enough to be using tin solders. So please continue to use Silphos and those types of brazing, not soldering. This starts the conversation about leaks, right? We do need to be careful about where we're running these line sets. We need to make sure they're protected so that there's no rubbing, no contact that could possibly cause a leak in the future. Our line sets need to be run with care, and they need to be done in a responsible way. And we know, I personally know that this is a bit of a pipe dream, but they are hoping that they're all accessible for inspection. Yeah, good luck, unfortunately. Tools. So tools is a big one. So with any new refrigerant, we need new gauges that can properly read the pressures and temperatures of that new refrigerant. We are a Kane UEI distributor, and all of their digital systems have been pre-made compatible with 454B and 32. It's just a selection in the settings, and so we're all good to go there. Vacuum pumps, even though vacuum pumps don't make any connection with the refrigerant per se, they are requiring that vacuum pumps are ignition proof, and of course reclaimers must be. So I'm finalizing a plan right now. We're going to come out to our customers with a truck stock package and say this is the base that you need to be able to operate on a daily basis with these our A2L refrigerants. There'll be a reclaimer, a vacuum pump, and then a gauge selection. Because we will offer analog gauges as well as digital and Bluetooth options as well. I think it's in here. I may have skipped over it, but as with any flammable gas, the threads on the gauges are left hand. So you can use standard hoses, but we will be selling adapters that take the right hand thread to a left hand thread. So left-hand threads on any A2L condenser and system going out. Nitrogen, obviously extremely important. They want to make sure that before you start welding, there is absolutely no oxygen in there, both for the combustibility range, but also, to keep the system clean. Extremely, extremely important. The other piece of this, I think it's, here. The manufacturers, this is a big change, the manufacturers are recommending a 600 PSI pressure test. They are really, really concerned about leaks. So obviously we're going to be using a lot more nitrogen. The key point here is 600 PSI is fine on a new install. The second those valves are cracked open, if there's a leak situation, you must close the valves before you pressure test. 600 PSI will break the compressor. No ifs, ands, or buts, right? The rest of the system have been tested at burst pressures far beyond that, but the compressor has not. So if you're doing a leak test on a existing system in a service capacity, you must close the service port or service valves to protect the compressor. So we're using the same POE oil that we did before. A quick piece about the POE oil. So back in the R22 days, we used a mineral oil that just slugged its way along through the system, and it worked fine. Once we moved to the pressures and the type of refrigerant that R410A is, the mineral oil wouldn't mix properly and wasn't able to be returned back to the compressor to maintain proper lubrication. So we moved to the polyethyl oil that we use now, POE. If you're not aware, POE oil starts out as an organic acid, and they put it to make the POE oil. They put the acid into a very large centrifuge and spin it up to a high speed. And when that happens, water is removed by centrifugal force from the acid, which leaves the acid as an oil. But it wants to be acid. It wants to be acid so badly that if we store POE oil in a metal container, it will pull water vapor through the metal and you'll have a jug full of acid. So these vacuums are extremely important, right? We must be vacuuming our systems, evacuating down to 350 microns. You lock the system off, shut your pump down, and you wait. If the system has not gone back up past 1500 microns, then you're good. If it has gone back past 1500 microns, you have water remaining in the system or some other foreign gas. If it goes all the way to atmosphere, obviously you have a leak and you need to go find it. This is extremely important for the longevity of the system. That if the oil remains in the system and there's still moisture there, it will turn back into an acid, and then it just acid washes the windings of the compressor until it doesn't take that many years for that acid to eat away the plastic that is coating the copper wires in the windings of the motor, and just one little short and bang, compressor's dead just because of a vacuum. So evacuation, extremely important. Fractionalization and dew points. So this is a quick one. I'm not going to dive too deep into this one, but it's important to know because just like 410A, 454 is a blend. So we all know that when we're charging 410A, we must take it out as a liquid out of the bottle. If you take it, the refrigerant out of the bottle as a vapor, you're only getting one of the refrigerants and you're unbalancing the blend because these blends, these two refrigerants don't have the same boiling point. So whichever has the lower of the two will be the only refrigerant that is in a vapor state in that bottle. So as these A2L, or sorry, R32 is a pure refrigerant, so this doesn't apply to them, but the 454B that we use and 410 right now actually fractionalizes and it separates inside the air conditioning system as it's working because they boil at different temperatures. So as these 2 or 3 refrigerants move through the evaporator or condenser coil, in this case, they will change state at different times. And that is helpful because it elongates the time that it is in a change of state, which can give us better capacity. But it is important to know that we still require the refrigerants being taken out of the bottle in a liquid state. And of course, the opposite is true in the evaporator. They will evaporate at a different rate. So, as with 410A, topping off minor leaks is still acceptable. But if you top off a minor leak more than once or twice, you really should consider pulling the entire charge out and recharging it with fresh refrigerant after finding the leak, obviously. Because it will leak out the refrigerant with a lower boiling point is more likely to leak out at a higher rate than the other. So you can actually find an unbalanced refrigerant in the system, which will not operate correctly. You will have a loss of capacity and will cause problems in the system. So if you have a leak that's what you suspect to be more than 50%, then you must pull the charge out because the balance of the refrigerant will be way off at that point. And you will have to fix the leak and, of course, put a fresh new charge in. Don't put the old refrigerant back in. So these, like 454B is a very similar refrigerant. Again, nothing changes on charging, except obviously don't smoke within 25 feet of the system or a bottle. Always charge with liquid refrigerant. Charge by subcooling when you are using an expansion valve, whether it's a thermal expansion valve or an electronic expansion valve. Always use subcooling. If you're using a fixed orifice or a capillary tube system, superheat is the way to go. This just shows the importance of liquid subcooling, vapor superheat, charging with one of those two in its complete state. If we try to do any sort of calculations in the middle where there's a saturation, then you're actually seeing saturation of 2 different refrigerants showing 2 different pressures. So your numbers will not make sense. This is an interesting one, because for those of us who were around during the R22 transition, it was extremely important that we left a written note of every change in refrigerant that we made to a system with our ODP license number, our name, our phone number, our company information. That is still in effect, but it will be very important to do in this case. Anytime we're changing the charge in a system away from the factory charge, it needs to be recorded, and those carbon copy slips need to be left with the unit, so the next technician coming in knows what the charge should be. Mitigation. So what happens if we have a leak? And what happens if we had a leak that leaked inside the house? How are we going to deal with that? So it's a simple goal, right? If the refrigerant is detected, turn on the blower, dissipate the buildup of any flammable gas, and turn off anything that could spark. Simple, right? How are we going to do that? So we're trying to minimize the system charge as much as we can. That's why we're using the 5/16 line set. That's the only reason to do it, right? 3/8 has been a standard for so long, but there is a good reason to drop it down to 5/16. Here's the one exception to most of what we've talked about here with mitigation. If, like we talked about at the very start, refrigerators use propane, right? But even though they're highly flammable, they're being installed in a factory conditions and not the charge is not being adjusted on site. Same goes with packaged units. So residential packaged units that have less than 4 pounds of factory charge are exempt from mitigation systems. So if you do these residential package systems, you may find them in the field into next year that don't have refrigerant mitigation systems built into them, right? So they need to be installed on every single split system. Package systems may not have them, and that's okay. For instance, an American Standard 2-ton, this American Standard 2-ton packaged unit has a factory charge of only 3.4 pounds. So they're doing their best to try to keep these charges low. So we will start seeing these refrigeration mitigation sensors in all of our equipment. The good news is that there are 3 different manufacturers of these sensors, and they all interchange with each other. So you can choose one of these sensors to keep on your truck, and you'll have the right one every day. You won't run into one that the plug doesn't fit. They have at least gotten together, and the Molex plugs will all fit together, and they all mount in the same way. The other thing, sorry, to go back to that, unlike gas water heaters with the flammable vapor ignition resistance systems built into them, these are automatic resets. They do not need to be replaced after an event. The sensors ship inside the coils, and they're installed in a way to find the lowest point. So in a coil, that's the drain pan, they'll be installed, clipped to the bottom of the drain pan. If you're using a convertible coil and you need to convert it to horizontal, you quick unclip it off the bottom and move it over to the side. Simple as that. And this is a picture of the internal. It's clipped into the drain pan. The refrigerant mitigation circuit board comes factory installed in air handlers, but it will be a field installed item with all evaporators. They will mount to the front of the evaporators, and this is on American Standard, ADP, also the same. They will be coming with the evaporators. And here's another change for you. Instead of your air conditioning low voltage wiring coming from the condenser and straight down to the furnace, it comes here. And then there's a wiring harness that goes from here down to the furnace. So that allows us to cut the power to the condenser if there is a mitigation sensor event. Like with the sensors, there are 2 board manufacturers, and luckily they've made them identical. So they may look a little bit different, but all the connections are the same, so they are interchangeable, which is, again, obviously great news for us. There is an LED diagnostics built into these boards, very simple, easy to follow. Any accessories in the HVAC system that are not directly into the airstream do not need mitigation. So HRVs, remote steam humidifiers, even the fan powered ones don't need to be interrupted. They'll most likely turn off anyways, and hopefully none of these three items are running and cooling anyways. But with heat pumps becoming more prevalent, it's quite possible that they would. These don't need an interruption circuit if a refrigerant mitigation system alert comes up. So the blower will continue to run, the compressor will turn off. These three types of items and others like them will continue to run as well if needed. These ones will not. Very important that any electronic air cleaner or other electronic device like a UV light, they need to be into the system to turn off if there is a mitigation issue. UV lights in the return air, obviously not that big of an issue. UV lights that are designed to keep the coils clean, that are right above it, probably a good idea to include them in the switchover or the circuit break. And it's as simple as this. There's just accessory terminals on the board, accessory 1, accessory 2, power to the accessory terminal. It's a dry contact, power out to your device, and common back to your common on the power source. Easy, nothing to worry about. Decommissioning. So just like now, there's nothing worse than some poor scrapyard person running their forks through the side of an air conditioner only to get blasted with refrigerant, right? Extremely important that we're taking out the refrigerant properly, safely. What they're asking for on A2L systems is that you write refrigerant recovered in permanent marker or some other marking, whatever you want to use, and your dealer name and the date that it was done. Again, HRAI is an excellent resource for any deeper information above this walkthrough that I've presented today. These green links are great for getting quick questions and asking the HRAI directly about any regulatory questions that you may have. Otherwise, that would be the end of the presentation today. Are there any questions? Yeah, looks like we're in good time too. We will be running, so I am running another one of these at 4:30 today. Identical presentation. If you think that you heard anything today that you think anyone else should take part in, and then as we learn more information and get closer to the end of the year, we'll certainly do this presentation again, and I'll add in anything new that I've learned from the HRAI and other industry and manufacturing partners.